Welcome to the CompTIA A+ 220-1101 or Core 1 exam. This is Objective 3.1 Network Cables. The cabling that's in your network is the fundamental communications path to the rest of the world. So it's important that you're able to use exactly the right cable for the job. If you're building a new data center or building a new building, you really only have one chance to get this right. So you want to be sure you're using exactly the right type of cable. And although we become very accustomed to using wireless networks, the bulk of our network communications take place over a wired cable connection. For our Ethernet networks, we very commonly use twisted pair of copper cabling. This is what it looks like inside of that Ethernet cable. You can see that we have 4 pairs inside of the cable. Those 4 pairs have different colors. One is a solid blue, one is blue and white, one's a solid green, and one's green and white. We have a solid orange, orange and white, a solid brown, and brown and white. These pairs of wires contain equal and opposite signals to each other. Sometimes you'll see these referred to as transmit plus and transmit minus to show you that they're sending opposite signals from each other. We combine this difference in signal with a twisted cable to be able to get this information from one side of the network to the other. You can see that these twist in them, and that means that the signal going through the wire is constantly twisting as well and effectively moving away from any type of interference as it's moving through the cable. When these signals arrive at the other end, those signals are compared with each other, and many interfaces that have occurred through the wire are identified. Because we now have 2 cables with different signals to be able to compare, another interesting bit of engineering is that each of these pairs has a different level of twist rate. So there may be a tighter twist on one pair of wires than another pair. This means that if there's interference to this cable as the data is moving through it, all 4 of these pairs will have different signals on the other end because they are all different twist rates. Of course, there's more than just one kind of twisted pair cabling. Through the years, we created a number of different types of twisted pairs. Each one of these types has a different set of electrical characteristics and supports different kinds of networks. We refer to these as different types of twisted pair cables as categories of cables. And in our Ethernet standards, we create a minimum category of cable that's supported by that standard. For example, in this chart, we've used different Ethernet standards. You can see a 1000 base T and a 10G base T. 1000 base T is 1 gigabit per second and operates with the twisted pair cabling. The other is the 10G base T, which is a 10 gigabit per second Ethernet that also runs over twisted pair cabling. If you were to look at the IEEE standards for 1000 base T, it supports a minimum of category 5 cabling to a maximum distance of 100 meters. And then you can see the different categories and distances that are supported for each column down below. Also look at the cabling and see how different the end of the cable is. Okay. Coaxial cables. Another type of cable we commonly use, especially on cable modems, is a coaxial cable. Coaxial means that there are 2 or more forms that are shared as a common axis. And that's certainly the case here. You can see the wire conductor is all one single conductor running the length of that coaxial cable. And around that is an insulator that also runs the same direction, with metal shielding around that and a plastic jack around the outside. This is commonly the type of cable that you would use inside of your home with your cable television or your cable modem. And it commonly uses RG6 as the type of coax cable. In your work environment, you might have to work in an area with a drop ceiling. And above that drop ceiling may be ducts that supply cold air and remove the warm air to send back to your air conditioning system. But with other environments, you may have ducts that provide the cool air, but the warm air is the air return going in a shared airspace that we call the plenum. The plenum is a shared area. So not only is this an air return, but all of our network cables are usually in the airspace as well. If we have a fire in this building, we want to be sure that our network cables don't create smoke or toxic fumes, which will then be grabbed by the air return and forced into every other part of the building. This means that if we have this shared plenum area, then we need to use a special type of network cable so that we don't create more problems during a fire. The jacket that is around the Ethernet cable is commonly called a PVC or polyvinyl chloride. We'll look at that in a second. For most cables that run, we're using UTP or unshielded twisted pair. This is a type of cable that doesn't have any special shielding around the cables themselves or individual wires. If you're using Ethernet cables at home, you're probably using UTP. In environments where there's much more interference or you want to add protection, then you would use STP or shielded twisted pair. There might be a shield around the entire cable, or the individual wires themselves may have a shield. Most of these shield cables will also have a ground wire for some additional protection. If you look at the outside of an Ethernet cable, you'll see some writing that describes what type of cable is on the inside. This uses abbreviations like U for unshielded, S for braided, or F for foil. In our picture of the shielded twisted pair here, you can see that there is a shield around the entire cable but no shielding around the pairs. So this would be F/UTP for foil. Here's another cable that has a braided shield around the entire cable, and each individual pair of wires has foil around it. The abbreviation of this is F/FTP, which means we have braided shielded / foil twisted pair. In this slide, we can see the different types of cable that I was talking about and the different abbreviations. So the first one you see is braided. It's braided and protected with the coating. The next one is just foil, and the next one is braid and foil. So we can put conduit and cables underground. These cables are designed to be outside, so they have a special waterproofing inside them, and sometimes they're even filled with gel that helps keep the water away from the cable that's on the side. This means you may be able to put the cable directly in the ground instead of running a conduit and then putting the cable inside of that conduit. These are usually shielded twisted pair, which certainly helps to prevent any type of interference, but it also adds some rigidity and strength to the cable itself. Here's a cross-section of a shielded twisted pair that we might use as a direct burial cable. You can see there are 4 pairs of the Ethernet cable, and around each of these 4 pairs is a waterproof gel, which then has a shield around each individual pair. This helps keep the water away from any of these pairs within the cable. And there is what we call a drain wire, which is not referring to water, but instead draining away any additional voltages through a ground wire that extends the length of the cable. Okay, we're at the end of 3.1 network cables. Here's a common question you would see on the A+. What cable types are compatible with 1000 base T? Choose 2. So we have Cat5, Cat5e, Cat6, Cat6e. Do you remember that table that we were looking at with the columns? Yep, 1000 base T uses Cat5, and then 100G base T uses Cat6. Thanks for watching.